Alright guys, so we're going to go through some example problems from our assignment that you need to work on with these videos. So here's what our key looks like so you understand when I'm going through these examples what we're boxing. Okay, and I'm going to warn you, we're going to do these a little out of order. Okay, so the first question we're going to start with is number 10. So we're looking at silver. So first thing you need to do is find silver on your periodic table. And it should look something like this. Okay, so we've got our chemical symbol in the center. We've got our number of protons up at the top. So that's our atomic number. And down here, we have our average atomic mass. Okay, so remember your atomic mass is your protons plus your neutrons. Okay, so we're going to have to go through and figure out some information about silver based on what we know. Okay, so if we're looking... Okay, notice how we don't have anything in this green box right here. We have nothing up in the corner. That is telling us that we do not have a charge. Okay, so we do not have a different number of electrons than what's on the periodic table. So that means our number of electrons is going to match our atomic number. So if we're looking, here's our atomic number. So we know that we have 47 protons and 47 electrons. Okay. Your atomic mass, look at the bottom under your element, and we're going to round that to about 108. Okay, so for this one, we need to find our mass number. So remember that our atomic number plus our neutrons is equal to our mass number. So we know our mass number is about 108. We know we have 47 protons, okay? But we don't know how many neutrons we have. So what we're going to do is just rearrange this equation. We're going to subtract 47 from 108. And that will tell us how many neutrons we have. Okay? So if we're trying to identify what type of atom we have, by looking at our symbol right here, if we just have Ag, okay, we don't have a charge, it's not written in isotope notation, then we are going to assume, okay, that silver is a neutral atom based on the information we were given. Okay, next one we're going to take a look at is number 2. So, number 2, we notice that we have our chemical symbol for hydrogen, so we're going to find out in the periodic table. Okay, but we also notice now that up here, where I got my little green box, we have a charge. So, it's telling us H+. Keep in mind, scientists are lazy. So that really is a +1. Okay? We'll get into how we find a number of electrons in a second. But again, looking at our periodic table, we find hydrogen, chemical symbols right here. Up here, we've got our atomic number. We know that we've got 1 proton. Down here, we've got our atomic mass, our average atomic mass. So we're going to round that. So that way we can find our mass number. Okay, so if we're looking, we know we have 1 proton. We know that our atomic mass is about 1. Okay, and we know that we have a charge of +1. So when we are finding our number of electrons, remember that if it's a positive charge, like this +1, it means that we've lost electrons. If you have a negative charge, that means we've gained electrons, okay? I know that seems a little counterintuitive, but keep in mind that your electrons have a negative charge. All right, so if we're trying to find how many electrons hydrogen has, we're going to subtract these two numbers, okay? Because in a neutral atom, this will be how many electrons we have. But we know we have a +1. Okay, so we lost that 1 electron, which gave hydrogen ion a positive charge. So, like I said, hydrogen would be an ion, and you can tell because it has this charge up here in the corner. So we have an unequal number of electrons and protons. Keep in mind, though, your atomic number does not change. If we change this, we get a new element. All right, our last example that we're going to walk through is number 4. So, right off the bat, you should notice, okay, that this has a different notation. So when you see what looks like reverse of what's on the periodic table. This right here is telling you that it's an isotope, okay? So they flip it. This right here is our atomic number. This up here is our mass number, okay? Remember that with isotopes, our mass number can change because we have a different number of neutrons, okay? So when we're looking at this, okay, we're coming back here. We know, excuse me guys, I just knocked over some stuff. We know that our atomic number is going to be 6. Matches what we find on the periodic table. This time, we're going to take our atomic mass number. We're not going to round like we did previously. We're taking the number straight from the notation. So if that said 14, we would use 14 instead of 12. Okay, and keep in mind, we don't have a charge. So we're coming back to how to find your mass number. So it's your atomic number plus your neutrons is equal to your mass number. So we know our atomic number is 6. We don't know how many neutrons we have, but we know that our mass number is 12. So 6 from 12 is going to be 6. We have 6 neutrons in this carbon isotope.